Now we focus on chapter 3. So chapter 3 about electrochemistry. In chapter 3 electrochemistry, it have the 3 subtopic. So subtopic number 1, 3.1 about galvanic cell, 3.2 about Nernst equation, and 3.3 about electrolytic cell. So we focus on the first subtopic, 3.1 about galvanic cell. This is a learning outcome for subtopic 3.1 galvanic cell. A. Student can be define the electrode potential. B. Student can be draw voltaic and galvanic cell. C. Student can be describe the operation of the voltaic cell. D. Student can be state the function of subbrief. E. Student can be express the half cell equation and overall cell reaction equation. F. Student can be illustrate galvanic cell using a cell. G. Student can be define standard reduction electrode potential and standard cell potential in a cell. H. Student can be draw and explain standard hydrogen electrode sheet. I and J student can be learned in tutorial class. What is the electrochemistry? So electrochemistry study of relationship between chemical chain and electrical world. They have the two type of electrochemistry cell. First, voltaic cell, as known as galvanic cell, and number 2, electrolytic cell. In electrochemistry, we have the redox reaction. So redox reaction involve oxidation and reduction process. This is the one example for the redox reaction between zinc and copper. At the oxidation side, we have the half reaction for the zinc. Based on the half reaction of the zinc solid produce zinc 2 plus ion and lost 2 electron. So oxidation, loss of electron. Second, in oxidation process, oxidation number increase. So like example from the zinc solid, so oxidation number is 0. So produce zinc 2 plus ion, so oxidation number the plus 2. So increasing the number of oxidation. Zinc solid is the called reducing agent. Reducing agent stands for the species that does the reducing, giving electron to the substance being reduced. At reduction side, student can see half fraction for the copper. From the half fraction of the copper 2 plus ion aqueous plus 2 electron to become copper solid. So in reduction process, gain of electron. Second, in reduction process, oxidation number decrease. So like example for copper 2 plus ion, oxidation number plus 2, produce copper solid, oxidation number 0. So decrease number of oxidation number. Copper 2 plus aqueous is the oxidizing agent. So oxidizing agent, species that does the oxidizing, taking electron from the substance being oxidized. So we look for the important component in galvanic cell. First, electrode. What is the electrode? Electrode is the object that conduct electricity between cell and surrounding, that have the two electrode, anode and cathode, are deep into an electrolyte. So this is the example for the position of electrode in our galvanic cell. So student can see it have the cathode and it have the anode, and electrode must be immersed in electrolyte. They have the two type of electrode. First, active electrode. Active electrode involved in half fraction, like example electrode zinc, electrode copper and iron. The second electrode is inactive electrode. Inactive electrode do not involve in the half fraction, example electrode graphite and electrode platinum. The second component in galvanic cell is electrolyte. What is the electrolyte? Electrolyte stands for species that can conduct electricity in liquid form, stand for molten, or aqueous solution. Electrolyte, it can be pure compound, example molecule water, and molten salt. The second may be aqueous solution of salt, example sodium chloride aqueous and sodium sulfate aqueous. What is the change of energy occur in galvanic cell or voltaic cell? In galvanic cell, use a spontaneous reaction to generate electrical energy. All batteries contain voltaic cell, so in voltaic cell or galvanic cell, chemical energy change to the electrical energy. So this is the example for component and operation of galvanic cell or voltaic cell. First, in galvanic cell, electrode must be immersed in our electrolyte, like example zinc electrode and copper electrode. Zinc electrode immersed in aqueous solution of zinc 2+ ion and copper electrode in an aqueous solution of copper 2+ ion. So student can be see at the diagram. So at anode, electrode zinc immersed in zinc 2+ ion, example electrolyte zinc sulfate. At cathode, electrode copper immersed in Cu2+ ion like electrolyte copper sulfate. Second, in galvanic cell, two electrodes must be connected by a wire. Third, two containers are connected by a short brief. And last one, a voltmeter is used to detect voltage generated. So now we study about the operation of galvanic cell or voltaic cell. This is the one example for galvanic cell between copper and zinc. For your information, student must be remember, in galvanic cell, electron must be flow from the anode to the cathode. So what happened at the anode and at the cathode? First, we look at the anode side. At anode, zinc metal immersed in a zinc 2+ ion electrolyte, example solution zinc sulfate. At anode, zinc have the more tendency to relieve electron. So student can be see half fraction for the zinc solid becomes zinc 2+, the loss of 2 electron. So zinc is the negative electrode, since it is a source of electron anode because oxidation occur at the electrode. During the process, zinc metal will dissolve and the mass of zinc electrode become decreased. So student can be see half fraction of the zinc after zinc electrode decrease. So zinc solid become zinc 2+ ion. So zinc 2+ ion enter zinc sulfate solution. So this is the process happen at the anode. Now we see at the cathode side. At cathode, copper metal immersed in a copper 2+ ion electrolyte, example copper sulfate solution. So during the process, the electron flow from the anode to cathode. So electron flow from the zinc metal move out through the wire enter the copper metal. At cathode, copper 2+ ion from the solution accept electron. So this is the example for the half fraction for the copper 2+ aqueous from the solution accept electron to become copper solid. So copper is the positive electrode as a cathode. At the cathode, student can see half fraction for the copper. So copper 2+ aqueous gain 2 electron to become copper solid. So from the oxidation number +2 become 0. So reduction occur at the copper electrode. During the process, copper 2+ aqueous from this solution gain 2 electron to become copper solid. Effect from this process, copper is deposited at the copper electrode and the mass of copper electrode become increased.